Some background information on sequences. A sequence is an ordered list of numbers. Basically, the domain is like the term number. So 4 means like the fourth term of the sequence, and then the range is the actual terms of the sequence. We use subscript a lot with sequences. So A sub 1 is something you're going to see a lot. That means the first term. A sub 4 means the fourth term. A sub 22 means the 22nd term. A finite sequence has a limited number of terms. So if it says 2, 4, 6, 8, and then there's nothing after the 8, that is a finite sequence. It has an end. An infinite sequence, they put the ... at the end to indicate that whatever pattern existed in the first part is going to continue. That would be an infinite sequence. A sequence can be specified by an equation or a rule. Here's 2 examples of rules. A sub n, oh, that's another one you're going to see a lot, so we should probably write that down. A sub n means the nth term. So the nth term is 2 times n. You can also write that as f of n. F of n would also mean the nth term, and then on the other side it defines how to get those terms. So here's some examples of rules for sequences. The first one is a sub n equals 5n minus 1. So basically, a sub 1, you're going to use 1 in place of n. So 5 times 1 minus 1. 5 times 1 is, and 5 minus 1 is 4. A sub 2, you're going to use 2 in there. 5 times 2 is 10. 10 minus 1 is 9. A sub 3, you're going to use 3. 15 minus 1 is 14. (20 minus 1 is 19. Are you already picking up on what the pattern is? What's the pattern? Well, we're multiplying by 5 and subtracting 1, but if you start with 4, how would you get from 4 to 9? Add 5, add 5, add 5. The next one is going to be 24. So our first 5 terms of our sequence are 4, 9, 14, 19, 24. And I put the ... to indicate that this pattern would continue. This is actually an arithmetic sequence because we're adding 5 to get from term to term. And you might notice that 5 is the slope of that thing. So an arithmetic sequence is like a line. It's an equation of a line, and the slope is what you're adding each time. But there's also sequences that look like this: 2 raised to the n minus 3. And this time it uses that other notation. So on this one, the first term, f of 1, would be 2 to the first minus 3. 2 to the first is 2. 2 minus 3 is negative 1. The second term, f of 2, 2 squared minus 3. 4 minus 3 is 1. And you could absolutely just start typing these into your calculator. You don't have to do them with mental math. You can just punch it into your calculator, let your calculator do all the work for you. You might have to if you don't know your powers of 2 very well. 2 to the third is 8. 8 minus 3 is 5. Anyone know what 2 to the fourth is? 16. 16 minus 3 is 13. And 2 to the fifth is 32. 32 minus 3 is 29. So -1, 1, 5, 13, 29. This sequence, it's a little bit harder to see what the pattern is because exponential whatevers were involved. Using exponents was involved. And then some sequences are just kind of funky. N over n plus 1. So our first term, we do 1 over 1 plus 1. That gives us 1/2. Our second term is 2 over 2 plus 1. That would be 2/3. 3 over 3 plus 1, 3/4. You could keep going like that. I'm just going to write them out down here. 1/2, 2/3, 3/4. Anyone know what comes next? 4/5, 5/6. If you kind of look straight across the top, we've got 1, 2, 3, 4, 5 across the top, and on the bottom, 2, 3, 4, 5, 6. Yeah, and that would continue. That would be a harder sequence to write a rule for because you have to try to figure out what that pattern is and then try to translate that pattern into mathematical expressions. So today we're going to focus specifically on arithmetic sequences. Yes, that word is arithmetic. For some reason, that's how we pronounce it when it comes to sequences. Arithmetic sequences are like our example in number 1. With an arithmetic sequence, the difference of consecutive terms is constant. So if I were to subtract these terms, 9 minus 4 is 5. 14 minus 9 is 5. 19 minus 14 is 5. You get 5 every single time. That number is called the common difference. So whatever is being added or subtracted each time, that is the common difference. So basically, arithmetic sequences are a result of repeated addition. We need to decide if these 3 arithmetic sequences, if they are arithmetic or if they are something else, and explain our reasoning. So the first one, how do you get from 2 to 5? Add 3. How do you get from 5 to 8? Add 3. 8 to 11. And is this also 3? Yes, it is. So is number 1 arithmetic? Yes, it is arithmetic. And the reason is the common difference is 3. D is the letter that we use to denote the common difference. Okay, number 2. From 15 to 9, I would have to subtract 6 or 4. 6. Help me out with my mental math. Subtraction's not my forte. 9 to 3, we subtract 6. 3 to -3, we're subtracting 6. So yes, this is arithmetic because the common difference is -6. So even though it says common difference, I'm looking at how do you get from the first term to the second term to the third term to decide if it's positive or negative. Okay, have you ever heard me say that subtraction doesn't actually exist? Subtraction is really just the addition of negative numbers, but if it helps, arithmetic sequences are the result of repeated addition or subtraction. I mean, really, addition and subtraction are the same thing, but yes, addition or subtraction is arithmetic sequences. All right, number 3, you can probably glance at this and give an answer for whether you think it's arithmetic or not. What do you think? Why not? Well, if we go from 1 to 1/2, that's, yeah. But if we really look at this, from 8 to 4, we're subtracting 4, then we're subtracting 2, then we're subtracting 1, then we're subtracting a half. That's definitely not the same. So it's not arithmetic. What's actually going on here is we are dividing by 2 each time. That's going to be called a geometric sequence. We'll talk about that tomorrow. So I'm going to say no, and then I'm going to write no common difference. This is the formula for writing arithmetic sequences. Remember, a sub n means the nth term. A sub 1 means the first term. N is the variable that you're going to leave in there. N is kind of like our x. And D is the common difference. So, in this first example, I know that my first term is 3 because I can see right here that my first term is 3. We also need to know the common difference. So what is the pattern in this sequence? From 3 to 8 to 13 to 18, we're adding 5. So the nth term equals the first term 3 plus parentheses n minus 1 times the common difference 5. Now, it would be great if we could just leave it like that, but it looks kind of messy. What could we do with these parentheses right here? We could distribute the 5. So we have 3 plus 5n minus 5. And then combine our like terms. Our final answer is 5n minus 2. Try doing the same thing in number 2 on your own. Find the first term, find the common difference, plug it in, and distribute and simplify. Here's what you should have gotten. Negative 8n plus 63. Your assignment is in Big Ideas Math, so it's going to give you the a sub n equals. You'll have to type the rest of it in. Do we need to do a third example of that type, or do you feel pretty good about that? All right, let's move on to the next one. So in order to use this formula, we need to know the first term, and we need to know the common difference. So here's the problem in this example. They tell us that one term is this, and they give us the common difference. They don't give us the first term. So I'm going to write the formula down, and then we're going to put in what we know. All right, and I'm going to point in here to what I'm going to use. So a sub n, I am going to use 48 in place of a sub n. So my 48 goes right here. I don't know what my first term is. But because I used 48, which term number is 48? 48 is the 19th term. So I'm going to use 19 in place of my n. So this a sub 19 tells me that it's the 19th term. That's what you're going to use in place of your n. And I know that my common difference is 3, so I can plug that number in also. The only thing we don't know is the first term. So if I do some math here, 19 minus 1 is 18. 18 times 3 is 54. Once you figure out your first term, you then have to take your first term and your common difference and plug it into that formula to finish finding the rule for the nth term. That is your ultimate answer.